Let's talk about alcohols. Alcohols have the general formula ROH, where R is any hydrocarbon chain. And I'm going to be using this notation with all the different classes of molecules with the different functional groups. And then we have the OH, which is a hydroxyl group. Okay. Students always ask, what's the alcohol that we drink? It's ethanol, which is, whoa, not what I wanted. Ethanol is 2 carbons with an OH off of one of them. Yes. Okay. They're used in industry a lot. This OH group is easy to work with. It's easy to react with. It's easy to take off and put something in its place, a different functional group. These guys can be flammable. They can be poisonous. Don't go trying to drink anything other than ethanol. You go blind or other similar health issues. Intermolecular forces. What type of intermolecular forces occur between alcohol molecules? There's 3 types. There's London dispersion, there's dipole-dipole, and there's hydrogen bonding. And hydrogen bonding occurs when I have an H attached to an O, N, or F. And since I have an H attached to an O, I'm going to get H bonding here. So if I had another molecule here, another alcohol, oh, it's got a couple of lone pairs, yes. This negative side of the molecule would definitely line up to be near the pretty positive H, and I would get some attraction here. Now, as intermolecular forces IF get stronger, physical properties start to change. The melting point would go up, the boiling point would go up, and their solubility in water, because OH looks kind of like H bonded to an O bonded to an H, solubility in water would go up. That's for an alcohol compared to a similar hydrocarbon. So for example, if I was talking about ethane as opposed to ethanol, which I just drew up there, and I tried to compare these two things, the alcohol would have a higher melting point than its cousin, plain old hydrocarbon. It would have a higher boiling point. It would be more soluble in water, but only when the number of carbons is less than or equal to 5. So this would work for methanol, the 5 carbon chains. When I get to 6 carbons, 7 carbons with an OH, 8 carbons with an OH, and you can pretend that I've got this huge carbon chain with an OH sticking off the end. Okay, 20 carbons, 30 carbons. This part of the molecule, this OH group on the end, becomes less and less significant as this chain gets bigger. And so therefore, after a while, it doesn't matter that you've got an OH sticking on the end. What becomes more important is this big, long carbon chain. And that's why we say that these properties are generally in play for carbons when the number of carbons is less than 5. There are 3 types of alcohols. Yes. Primary alcohol is attached, the OH is attached to a carbon that's only attached to one other carbon. This is a primary alcohol. A secondary alcohol is when the OH is attached to a carbon. It's attached to a carbon that's attached to two other carbons. Doing that over here. The OH is attached to a carbon that's only attached to one other carbon. OH is attached to a carbon such as two other carbons. And in the last case, a tertiary is when the OH group is attached to a carbon that is attached to three other carbons. So three kinds, and their physical properties are also different, and we're going to be doing a lab about that later on. Finally, naming. It's just like naming an alkene or an alkyne. I'm going to use the ending OL, and I'm going to use a locator number. So I didn't even put an OH group on this guy. Let's put the OH here. I'm writing in green. So I've got, I gave you the advice before. Now I need the longest continual carbon chain that has the OH group, and that is this guy right here. I've got two branches sticking off, methyl and a methyl, off of number 1. So these are off of number 2. So we would call this 2,2-dimethyl propanol. Okay. Oh, dimethyl. I made a mistake there. I have to insert. I didn't say where the OH group was. See how easy it is to make a mistake? I got to insert a little 1. The OH is off carbon number 1. I need to insert a little 1 right in there. I'll do better on the next one. Longest chain, I will circle it because that's the advice that I gave to you. Longest chain seems to be 6, so this is a hex. Should I start numbering here or should I start numbering here? If I'm going to use the ending OL, it is the most important thing in the molecule. It must get the lowest number possible. That means this is going to be number 2, and that's going to be number 5. So this is 5-methyl. Now I have to say where the OH is. 2-hexanol. And the last guy, I've got 2 of them. One is off of number 1. One is off of number 2. Yes. Prop. Now this is, there's 2 of them now, and so we write a diol. Yes, a diol. Again, this A is put in there to make it sound better. Instead of propdiol, it's propadiol. Okay? And so that's our look at alcohols.